السلام عليكم ورحمة الله وبركاته. Welcome everyone today as well. اليوم هو الخامس من سبتمبر 2020. If you don't mind, I'll be recording this session because there were people who were asking me about recording it. So it's recording as we say. أنا تامر النخال من Cambridge, and we'll just wait for another 30 seconds or so. This is a series of lectures where we talk about researching. We started the first lecture last weekend, and we spoke about, of course, how to conduct research, etc. I will see what's with the waiting room. Everybody should be able to come in, to be honest with you. Yeah, I'll just leave it on the side. Yeah, I think everybody should be able. If I can ask you all to mute your microphones, and that would help us during the session. It's quite a condensed session in basic statistics, and I think it's very important for anyone who would like to initiate a small little project like a meta-analysis, as we said last time, and how after conducting the Prisma flow would be. يعني هاي series of 7 محاضرات. كل محاضرة حتكون زي ما حكينا ما بين 35 دقيقة و 40 دقيقة. And then afterwards, of course, we will probably start our own research paper. I think, yeah, we are recording, so that's for sure. And we have admitted everybody. It's just because this is a very intense lecture, and I would rather somebody join us at the very beginning, and hopefully you will enjoy. So I'll wait for another 30 seconds, and then we can start. At the end of the lecture, hopefully you will be able to know a little bit more than what you know. Oh, as you may know, you can chat. So if you want to have any questions or anything, so hello and welcome. You can write your questions, and at the end of the lecture, we'll try to answer them as we go. All right, so I think that's pretty much it. I would like to start now. Yeah, I think that's pretty much it for now. Fine. So I hope that everybody can see my screen. I'm sharing it with you. This is just a picture I took, of course, in Amman last year. And of course, this is kind of very important to notice that this is a picture taken in one side of the Colosseum, which is Al-Mudarraj al-Rumani. And of course, because it's just one side, you don't see the other side. And of course, in places like, you know, if you're doing research, you have to see both sides when you're doing or interpreting any research. Okay, fine. So as I said, I'll be going along. So first thing we'll start. يبقى أنت جمعت أو أنت جمعتي الداتا, and you started doing your Prisma flow. And as we said in the last time, and of course, that data, whatever you've collected, هتبتدي إنك تحطهم في graph. فعندك حيكون في, let's say, 20 people, 30 people. You will put it on y-axis and you will put it on x-axis. وحيطلع بالآخر جراف. الجراف هذا ممكن يكون شكله بيشبه هذا الجراف اللي هو في أعداد مختلفة وفي النص بيكبر العدد وبعدين بيقل. And this we call it a bell-shaped, yeah, distribution. Or we call it symmetrical distribution. لكن أحيانا الدata is very variable. And when the data are variable, then you know that the data itself will be not bell-shaped أو حاجة بيسموها skewed. يبقى كل اللي بدها تطلع من السلايد هاي is that we have two types of data. One of them is skewed and one of them is normal distribution. Normal distribution يعني the data are following the bell curve appearance. whereas skewed, which means that the data are not following a particular pattern. Yeah. So let's say if you have coronavirus and the number of infection rises within 2 weeks and then goes down, that's called a normal distribution لأنه we know حيكون في peak وبعدك حينزل. لكن أحيانا if the government is not doing the measures, etc., a number will be slowly coming down, but at the same time you know that there is no particular anticipated curve. And احنا مش عارفين, we can't really make sure that this is the middle of it. Okay, so going into that, you've got the first slide. We will speak about all the 3 M's, or what we call the mean, the median, and the mode. Mean يبقى هو كلهم يعني نوعا ما المتوسط. And remember, if you have this bell distribution, that means that the mean المتوسط حيكون في منتصف الفigures, and because it's symmetrical يعني النص اللي فوق زي النص اللي تحت. So the upper half equals almost the lower half في الداتا set اللي انت حطيتهم او انت حطيتيهم في البلوت itself. So with the skewed data, لو انت عملت نفس الفكرة, when you started doing a mode or a mean for it, you can't really figure out the middle of that figure. And then we would need to have a mean. Simply putting, mean هو average or midpoint of the data that is normally distributed في bell shaped distribution. لو حيكون في المتوسط تبع as you say في متوسط symmetrical distribution. لكن بالنسبة للميديان, this is the average when the data is not symmetrically and it's usually skewed. Yeah. So when the data is not symmetrical or skewed, it's a point which has half the values. يبقى نص الvalues حيكون above ونص الvalue يكون below. يبقى في فرق واحد بس بين الاثنين, بين الميديان والمين. الاثنين is a value that is in the middle. If it's bell shaped, يعني انت متاكد او متاكدين انه البيانات حتكون متساويه زي ما انتم شايفين in this symmetrical distribution, we will use mean. لو كان في skewing of the data, then you would use the median. احيانا الميديان is hard to find, so we use something called interquartile range. هشرحه كمان شوي أكتر بالتفصيل. And there is the less likely for you to read in any paper, which is called the mode, which is the most common of a set of events. يبقى كل what's we're planning from this slide, there is something called المتوسط, which is either mean or median. If it's symmetrical distribution, then you'll use a mean. If it's skewed, وقلنا skewed that it's not symmetrical, الداتا لما اجيت اعمل لهم analysis ما كانوش symmetrical, you will use median. That's it. Interquartile range. هاد تبع الميديان. This is related to the median. And they divide, simply putting, the data that you have collected into 4 quarters. يعني قسموا الداتا, انت عندك 100% sample وراحوا قسموها. فرضا بدك تروح ترتبهم حسب العمر, فراح قسموهم ل 25% و25 25 25 يعني أرباع. Each one of these is called a quarter, عشان هيك سموها quartile. Yeah, and this is interquartile, which means ايش الربعين, or what are the 2 quarters that will make up the majority and the middle of the sample, يعني منتصف السامبل. لأنه لو كان عندك واحد عمره 2 وواحد عمره 100 سنة والأغلب ما بين 40 و 60 سنة, then you would know that the interquartile range will be a bit higher. And this is تبع الميديان. Yeah. So in data that is skewed بمعنى it's not normal distributed, which means that there is skewing of data. كلمة skewing of data يعني عندك range of data that is very wide. يعني طفل عمره 2 وواحد عمره 100 سنة, لكن الأغلبية فوق 60. لو أخذت المنتصف ما بين 2 و 100, 102 على 102 على 2 حيكون what? Let's say 51, and it's not true لأنه مش أغلب المنتصف هو 51. المنتصف حيكون 65 لأنه الكيرف حيكون skewed, what we call in English. So that's how we calculate the interquartile range. يبقى هو الكوارتر الثلاثة, so Q3 نقص منها Q1 وحيطلع الرينج تبعنا اللي هو الميديان أو الانتركوارتايل range. And this is more accurate لما تيجي تقرأ paper. Anyway, this is all kind of just to show. It's a bit of a lot of information to take in, but you need to know some of the basics. There is something called normal distribution. يعني لما كل الأعمار تكون صح أو يكون حاجة اسمها skewed distribution لما يكون عندك wide range, small and large number, and the mean is not in the middle itself. Then you would need to have a median. Let's move next to a standard deviation. لو أنت بتقرأ في a paper and you read something called a standard deviation. So we use it for data that are normally distributed. Okay, so again, a data that follow the normal distribution. Normal distribution يعني لو أنت حطيتهم كلهم على ال y وال x axis, you will find this nice bell curve. Okay, and it provides information on how much the data vary around the mean. Okay, so again, يبقى normal distribution يبقى عندنا mean وحواليها لازم يكون في alteration. الالتريشن هاد يعني فرضا لو حكينا اغلبهم كان اعمارهم ما بين 20 و40 يبقى المنتصف حيكون قديش؟ 30. So the middle would be 30. And you would say that the standard deviation really is 10. يعني يا إما كان 40 يا إما كان 20. So plus minus the standard deviation, which is the 10 here في المثال اللي أعطيتكم إياه. أو مثلا distribution of weight, you will find مثلا 80 كيلو is the mean and the standard deviation is 5. يعني how much the mean is deviated from its standard by 5. يبقى الانتسيبيشن انه اغلب اللي في الريسيرش اللي انت عملته حيكون ما بين 75 كيلو وما بين 85 كيلو. تعال نفهمها اقرب in the bell curved kind of graph. So this is your all numbers. كل العيانين اللي انت اخذتهم حيكون هيك كل البيشنتس ولقيت انه الديستريبيوشن تبعهم كان بالضبط يشبه البell curved. I wouldn't be able to admit other people after, of course, this because it will be too sophisticated. So لما تيجي تعملهم analysis للstandard deviation حيكون المين هو المنتصف يبقى this is the 50 percentile, yeah? لما تيجي تعمل standard deviation يبقى how much the data vary around it, which will include the most number of people or the particular set of values in that research. يعني مثلا لو هم كلهم كانوا 80 كيلو او ال100 يعني عندك هنا 20 30 40 50 كيلو 60 70 80 كيلو 90 100 وهكذا. How much of those يعني تقريبا 68.2% من those people are within the range. فبالتالي عشان ياخذ المقطع الأكبر للناس في particular study, you will need to have the mean, المنتصف, which is the 50%, okay? But for that to happen, you have to have normal distribution. All right. And then you'd need to know how much is the deviation to get the biggest number of the population. يبقى بقديش بيبعد value معين اللي هو بنسميه standard deviation عن المين اللي هو ال 50th percentile بحيث ان I am including most of my data set. يبقى mean is, let's say, 50th percentile, and then one standard deviation is ال5 كيلو اللي زيادة, and one standard deviation below the mean, which is another 5 kilogram below it. So that's the range for SD1 or standard deviation value of 1. لو جمعنا ال SD1 كلها على بعض حيعطيك 68.2% of the whole data that you've collected. Now, if you move into further into to include more, which is like 2 standard deviations, then you will get 95.4% of the data, which means that you're only, if you have any errors, that will be by less than 5%. يعني الأغلب ال patients that you've collected or whatever data you've collected لو ال 5% اللي بالآخر هنا على الأطراف, this would not affect your study. Okay, so this is how you would need to start slowly understanding standard deviation. But watch out. لما نيجي نحكي standard deviation, for example, for hospital stay data with a mean stay of 10 days, يعني عندك مرضى اجوا على المستشفى وضل نحكي احنا المتوسط تاع العيانين كانوا في المستشفى 10 ايام. with a standard deviation of 8 and you've calculated a standard deviation of 8 ماشي, which means لأنه المين تبعي هو 10 يبقى المتوسط 10 و2 times the standard deviation. يعني لو رجعنا وبدنا include the most population حيكون تحت 2 standard deviation, يبقى هاي 1 standard deviation and 2 standard deviations. Okay, so which means that is 2 standard deviation. لو كان 1 standard deviation 8 يبقى 2 standard deviation حيكون 16. 10 ناقص 16 or 10 minus 16 equals minus 6. How can somebody be in hospital for minus 6 days? This means that this test is wrong in here. And here you would need to have the interquartile range. لأنه we have different variation في values. عندك عيان تبع appendix حيكون لمدة يوم, لكن عيان تبع laparotomy حيكون 20 يوم. So in this, the data is skewed, and the best appropriate is to translate it into interquartile range. يبقى الميديان هنا حيكون الصح. Again, clearly this is impossible, so the mean and standard deviation is not the right thing to use. ننتقل إلى confidence interval. What is it used for? المين بيعطيني سناب شوت الفاليو اتس 1 فاليو على 50% من الكيسز. يعني لو قلت لك واحد عمره 40 واحد عمره 20 المين حيكون في النص 30 and this is just a value. لكن when you're doing a population based research مش حينفع تحكي انه this is just one value and this will be applying to the whole population, and hence you'd need to have an interval. محتاج يكون مدى, يعني المدى حيكون من وإلى. So it's used when instead of simply wanting the mean value of a sample size, you need a range actually that is likely to contain the true population value. هلا الرينج هذا is the mean value. يبقى هنا صار في مش mean little kind of value. No, it's a mean range now that we could get if we had data for the whole population. يعني instead of just giving a sample size, لو أخذت عينة صغيرة هتعمل mean. لكن لو أنت بدك apply it to the population as a whole, then you would need to have a range, because that will be implemented to a bigger sample, and then you would have a better look على confident. And so why are we doing this, or what does this mean exactly? So statisticians can calculate a range, وهذا اللي هو interval, or what they call an interval, in which we can be fairly sure, which is like confident. That's why we call it confidence interval, that the true value, which is actually the mean that we are calculated, lies in it. It's simple terms. It's a range that we are confident that most of the population on Earth or population anywhere will actually will have that mean truly in it. Okay? يعني this is the sample size اللي احنا أخذناها. Look at this graph here. And this is the mean, the normal mean, yeah? Which is a value. But to be confident, you need to be confident that this is a population that if you apply it to the whole world, then you're 95% in here. Be confident that the mean will be in there. So let's say you've taken a sample in America, you've taken a sample in the Africa, you've taken a sample in, let's say in Asia, and the mean in Africa was 30, the mean in Asia was 10, and the mean in America was 40. So if you calculated the confidence interval, the interval would be between 10 and 40, which means that most of the value, the mean value, المتوسط, حيكون in that confidence interval. Simply putting it, it's a range, an interval, which we can be fairly sure, confident, عشان هيك اسمها confidence interval, that the true value lies in it. انتهى. So an example, we have a new antihypertensive drug on the market. Yeah, and we are interested in knowing the reduction in blood pressure from a sample treated patient. We can work out the mean, but the mean is for our particular sample. يعني لو بدنا ناخذ بس المين حيكون بس particular sample اللي هي تبعتنا. However, لو بدك تطبقها في الحياة العملية, this is not true, because you have a bigger sample في الحياة, which is the whole population. So here we would need to have a confidence interval which will give us the range for the true value itself. Let's have a look. So we have the example, عندك hypertensive patients, المين تبعهم is 170 systolic, And the first study has got 100 participants. N means the number of participants. And we've given them the pill, the new pill, and it dropped the systolic by 20 on most of the cases. So if we are 95% confident that it is between 15 and 25, okay, this means that we can be 95% confident that the true effect of treatment is to lower the blood pressure by 15 to 25. Very straightforward. Yeah. يعني لو لقيت في الورقة مكتوب confidence interval is 95% and it's between 15 and 25, this is your kind of mindset of thinking. However, study B, for the same drug, they've included only 50 patients. Look at the sample size, it's smaller. And they've given the tablets and it lowered down the systolic blood pressure by 20. But look, they've written in their paper, the confidence interval is 95% from -5 to +45. Wait a second. This confidence interval has 0. يبقى في الرقم 0 في الرينج هذا من -5 ل 45, which means that there is no change. بما معناه انه عند الصفر معناته ما في تغير لانك تعطي هذا الميديكيشن، وهان بيبدا في مشكله. This means that there is more than 5% chance that there was no true change in blood pressure and that the drug was ineffective. يبقى في ال 95% اللي المفروض انا اكون sure انه the drug is effective في عندي value of 0 او حتى -1 يبقى there is no effect. يبقى this confidence interval is not applicable. يبقى لاحظوا انه there are two studies and one study didn't kind of conclude that the drug is not effective, whereas here the drug is effective. And that's why we need to know that the confidence interval is usually linked to the sample size. The bigger the sample size you take, the more confident you are that this sample size will represent the population. So the bigger the sample size, the better you will be having significant values. Okay, so as of last time, we did the Prisma flow, and we discussed a little bit on how to do literature review. So we went into PubMed, and we typed all the keywords, and we found 5 relevant studies to that particular thing, and did one to calculate the mean. عندي كان في trials معمولة في بلدان مختلفة، واحدة في هولندا، واحدة في ألمانيا، واحدة في مصر, and so on. And they have different 5 results. So here we use something we call meta-analysis. Meta يعني نهاية, yeah? وanalysis, which is analysis of the نهاية, which means الزبدة أو الزيتونة زي ما بيحكوا. This is the cream of على cream لكل الpublications اللي اتعملت around this drug. Okay? So here we use systematically assessing the results of previous research to derive conclusions about that body of research. يبقى عن antihypertensive, the example I've given you. And we, after all the Prisma flow, we've done the literature review, we found that there were 5 papers, study A, B, C, and D, and E. اللي من PubMed, okay? And then we've plotted something called forest plot. We've plotted something called forest plot او اسم تاني له بلوبوجرام، وحطينا هنا الكونفيدنس انترفالز والرينج تبع البلاد بريشر. يبقى هذا عندك التغير في البلاد بريشر here, and each study وقبالها قديش كان الكونفيدنس انترفال والمين. اوكي الخط هذا يعني مين. I'll show you. So this is the mean, and الرينج اللي انت شايفه او it's the confidence interval. So the range is the confidence and this is the mean. And at the end, the statistician calculated something called a combined estimate. لما تقرأ على ورقة combined estimate معناته they've done some sort of a statistical sophisticated analysis وطلع لي من ال5 ورقات هاي mean واحد أو confidence interval واحدة لكل البيبرز. And this we call the diamond shape الأسود. This is called the combined estimate. So a statistician has combined the results of all 5 studies and calculated that the overall mean reduction is 14, يعني أو 12 to 14. So the mean was 14 and the confidence interval was 12 to 16. يبقى الدواء هذا قلل لي البلد pressure from 12 to 16 والمين كان 14. Okay, so all you need to know, there is something called meta-analysis, and it's actually the combination of all our systematic reviewing and analyzing all the data that are published on a particular topic. There is something called the mean, there's something called confidence interval, and there is something called forest plot. And now you understand this plot in a bit more details. Okay, good. So ايش الفرق ما بين الستاندرد deviation and confidence interval؟ الستاندرد deviation قديش بعيد عن المين؟ يبقى how about the variability or spread of the sample. الconfidence interval it tells us the range which the true value المين حيكون فيها، يعني قديش أنا متأكد إنه المين حيكون فيها. Simply putting. Now to the next chunk of this day, which is called the p-value. So far you know what is a confidence interval, you know what is a standard deviation, and the last thing today to know is the p-value. And this is very important to understand because you will come across in every other article. When we wish to see how likely it is that the hypothesis is true, زي ما حكينا المرة اللي فاتت, we have always a hypothesis, بنحط نظرية. And the hypothesis is that there is no relation. الستاندرد أو يعني الديفولت تبعنا كلنا إنه ما فيش علاقة بين شغلة والتانية. وإحنا بنعمل التست عشان نبروف إنه actually الكلام هذا غلط. إنه actually there is a relation, there is a significance difference. So hypothesis is usually that there is no difference. وهذا مهم جدا إنكم تفهموه. إنه hypothesis معناته لا يوجد علاقة, yeah, between two treatments. And this is called the null hypothesis. So p-value gives the probability, احتمال, of any observed differences having happened by chance. يبقى هيحكي لي ال p-value هتحكي لي قديش نسبة إنه الإشي الريزلت اللي طلع لنا is happened by a chance, بالحظ طلع. Okay, so let's have a better idea. لما تلاقي في paper written p-value of 0.5, معناته إن ال probability احتمال of difference having happened by chance is نص في الواحد. It's simple putting, يعني 50-50, so 50-50% chance, which is not significant. يعني أنت بتلعب a coin, and this is of course not significant. Okay? هلا لو جينا, if you have a look at the bell again, so this is your confidence interval, وهنا ال p-value. لو طلعت لك رقم هنا, in this kind of اللي هو ال 5% اللي بعاد, and you think, well, did it happen actually by chance or not? You'd need to run a p-value. So you ask the statistician to calculate a p-value. You're not, it's not your kind of job. And the p is 0.05 this time for another study. So that means the probability of difference having happened by chance is 0.05 في كل واحد. يعني simply putting واحد في كل 20. يعني إنه من كل 20 sample you'll have one sample it possibly could be happening by chance, which is more significant of course. يبقى هنا there's more association. So this is the figure when they say statistically significant or unlikely to have happened by chance. لما تسمع كلمة statistically significant يعني it is unlikely that it has happened by chance. يعني مثلا we'll have in a second an example. So let's say a p-value of 0.01. What does that mean? That's actually, if you go back, it is 0.01 in 1. Yeah? So that means that it's highly significant, which means that the difference will only have happened by chance في واحد لكل 100, which is less than 1%, yeah? Or 1%. Again, I like examples. So now at least you know that there is something called a p-value. And this is the value to test our probability of something happened by chance, بالحظ. So let's say normally, you know, if we have 50 new babies, طبيعي, nature, you'd think that around 50% of those by chance will be girls, will 50 will be by boys. So a company developed a new drug for fertility. And you're asking your question, will it affect having a girl if I want a girl? And null hypothesis تبعك that the treatment doesn't alter the chance of having a girl. And there is no relation between the new drug and having a baby that is a girl. Yeah? So we start doing, you know, observing. After a while, you collect data and you find actually from those 50 babies, we had 15 girls. How interesting. And then did this happen by chance or due to a drug? So you give the drug and you have a girl and another girl and another girl. And you think, did this happen by chance or is it due to the drug itself? So here you need to know about whether the p-value will give you the kind of what is the chance of it. So you calculate the p-value, and the p-value is 0.007. This result would only have happened by chance in 007 in 1, يعني في واحد لكل 140 حالة, which means that it's not by chance, it's highly significant, which means that you reject the null hypothesis and you say, actually, there is an association between the new drug and having new babies who are girls. Yeah, this is the mindset. So remember, null hypothesis is generally opposite to what we all actually are interested in findings. So there's no relation. If we are interested, if there is any difference between two treatment, then the null hypothesis would be that there is no difference. And you will need to disprove it. You're not proving, you're disproving the null hypothesis. What influenced the p-value? Of course, as we know, the sample size. كل ما كان sample size better, bigger, you know that the p-value will be more significant. And remember, p 0.05 is significant, 0.1 is highly significant, and if it's 0.01 is very highly significant, okay? So, as part of our kind of course, whoever would like to participate in our homework, there will be welcome. The homework will be if you scan this QR code, or you go with your mobile, or you can go into the monkey survey and type in this, or you can just write it down. And then you would go and read the following article, and I'll show you how to read it with the PubMed index, and this is the number. And then if you submit the monkey survey, that would be enough. If you can't submit the monkey survey and you'd like to submit the questionnaire to myself, it's as well, you're most than welcome. Now, why we're doing this, I want to see how active you are after this lecture. And of course, there will be certificates at the end of the lectures for whoever does the homeworks. So just to show you about the PubMed indexing in a second. So if you type in PubMed ID and you take the number, each article, if you go to PubMed, yeah, and you just copy and paste the number or put the number and put search, you should be able to find the article, yeah? So, or if you write in PubMed ID. Okay, so if you just put the number, and you always can see that there's the number of the article, and this is the article that you will be able to read. If you are unable to download it, let me know, and I can send it to you. But as we said, you'd need to download the paper, and it's a meta-analysis, and read it, and then answer the 7 questions. They are very small questions about just what is the confidence interval, etc. I'll show you here. It's just about, so if you open the monkey survey, and you'll find that there's what is the impact of the journal, what is the null hypothesis, what type of study it is, what's the p-value, and then at the end, your name and your email address, and that's of course for the certificate. So if you are unsure about the question, first thing first is you have to find the answer to it. And this is by initiating you to research. The simplest way to put it, you can go to Google and Google it. And I've Googled what is an impact factor, for example, and I know that the impact factor is the yearly average number of citation that articles publish in 2 years' time. And I knew that the impact factor of a journal, there is some form of calculation which you don't know. And I can find, for example, a BMJ, which is a known journal, yeah? BMJ is a known British medical journal, and you can just write impact factor, and you will straight find it here. That's 30, which is high. But it's worth just knowing what's an impact factor. Of course, we will have more discussions around it. So this is to conclude today's session. Now I'll go to the chat room and find out if there is any questions. Of course, I hope that today we've done a bit of statistics. It's very primitive. Next time we will have statistics continued, which was going to be part B. And that's, I thought statistics will be divided rather into 2 lectures rather than 1, just to simplify it. And you're more than welcome to ask any questions at this stage. So, okay, to sum up the mission is simply, you need to type in the PubMed ID for this. You need to download this article and then read it. And then go to Monkey Survey. You can either now scan the QR code, or you can ask me to send it to you, or you can just go to Monkey Survey and type in the link, or well, ideally, if you want the presentation, I can forward it to you and then click on the link and answer the Monkey Survey. Alternatively, if you have any questions, you can submit it also to myself with the same questions that are on Monkey Survey if you wish. But of course, include your email as well as your details. Yes, so with a copy of the Monkey Survey, I would be more than happy if you, whoever wants the copy, if you could email me and I will send you the copy itself. Otherwise, you can just take a screenshot and type it in, or you can take the QR code and that will take you straight into the Monkey Survey link. If you, with your mobile phone, take the QR code, it should take you straight to this. Yes. If you have any further questions, please do ask at this stage. So to sum up, the most important things we learned today is number one, that there is normal distribution and skewed distribution. And then we knew something around mean, and this is for normal distribution, and median, and this is for skewed. And we knew that if we are using a median, we can use something called interquartile range. And then we read a bit about standard deviation, and we knew that standard deviations mean that 95% of people will be in the first standard deviation, and 68% will be in the first standard deviation, and 95% will be in the second standard deviation. And this is a range, yeah, around the mean. And we knew that if you're doing a median, that wouldn't be a standard deviation. And then we knew about the confidence interval, and this is how confident you are that the range that you are putting lies in the true value. وعرفنا إنه the true value, it is the value that the mean will be in it. And then we had an example. And then at the end, we kind of went through a literature kind of review and Prisma quickly. And we find 5 relevant articles. And we talk about forest plot and how to understand it. And we talked about the combined confidence interval. And then we ran quickly through a p-value. And hence, you know now that at least there are 3 things you know to know, which is if p is 0.05 is significant, 0.1 is highly significant, and 0.01 is very highly significant. Again, at the beginning, you will find it a bit hard. Don't worry. If you start reading and catching up, start with the article, answer the questions. I'm more than happy to answer any questions that you would like me to answer. The PowerPoint of the lecture, if you email me your email on my email address, or even on Instagram, and it's dr.elnakhal@gmail.com. I'm more than happy to send you to share the slides with you. Otherwise, I'm in the process of formalizing all the lectures and putting them on YouTube as well, because we're recording it. I hope that you've enjoyed today's session. It is condensed. There's a lot of things, but the major thing is make it simplified. Don't overthink it. And it's not your job to be a statistician. Your job is to understand what does that mean in an article when you read it. Yeah, and please, 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 if you're kind of very keen, do the homework. It will give you further insight towards it. And again, as I said, you download the article, you go to PubMed, you type in this number with PubMed ID. You should find the article, download it, then either you scan the QR code, and that will take you directly on your mobile to the link, or of course do Monkey Survey and submit it. Again, shukran كتير. Thank you very much for all the attendances. It's been a hectic lecture, but you can do it. Thank you very much.